first session of tech school. We did a session like this actually last semester at USC. It went really well, but everything was in person. It was that interactive. We actually had people giving us questions ahead of time and then starts asking us questions on different technology things. So this is how we kind of want to do it this time. We actually have Zoom, which I think works out really great. So if you want to have questions for Stephen during the session, just post it. You can use the Zoom chat and enable that. And then periodically during the session, what we'll do is just see if we can answer a few of the questions. And we also will probably post questions too that we don't know, links to certain things too. I know a lot of times when I was teaching certain technology things, I always want to give someone a really good example of it because technology sometimes there's some acute things there that need to be done. So we're thinking about a better way of doing that, but we'll probably just like post it. All these videos will be on YouTube, and you'll get all that information through our website. But further ado, Stephen, thanks for doing everything and coordinating everything for this. Stephen's leading our advanced technology team at Fōkcus for a few years. He's a great technologist, definitely has like a special gift in those certain variety of technologies, but he also is a really great teacher. He's been teaching our interns, and we've done a lot of things kind of internally, these tech schools for years. This is kind of like our external version of it, but he's been amazing at teaching all of us new things and new concepts, kind of like these one-on-one classes. He went to school at Linfield College in Oregon, and he also went to USC, where I went to school at for engineering. He was a guy's master's in computer science. So without further ado, Stephen, I'll hand it over to you.
All right, thanks, Curling. Give me a second here. I'll share my screen. All right. Yeah. So thanks for the intro, Curling. Like Curling mentioned, you guys are welcome to post comments or post questions in the chat here on Zoom, or on YouTube. I think there's a link for that too. So, and I will try to periodically, check and see if there's any questions and maybe answer them as we go along, to kind of help you guys out too. So be open to, if you have questions, be willing to post them on there, and we'll try to get to as many as we can. All right. So today we're going to talk a little bit about big data and machine learning. These are kind of buzzwords, kind of hot topics, or they have been over the past couple of years. So we're going to try to give you guys kind of an intro to this. Hopefully you might learn something today that you didn't know before, and hopefully listening through this today is valuable for you. You guys find some value from it. So what on earth are we going to be talking about today? So first and foremost, we're going to talk about what big data is, what that encompasses, and how that impacts our lives today, and how that's kind of impacted our lives over the last few years. We're then going to transition and talk a little bit about the cloud, how that technology has kind of emerged, and what that means in terms of big data and how that's useful. Then we're going to transition from that into machine learning. What on earth can we do with all this data? We're going to talk about machine learning as one of those avenues to use that data and how that's useful today. And then we're going to talk a little bit about what the future holds, what that looks like moving forward. And yeah, so that's kind of the agenda for today. So hopefully that gives you guys kind of a roadmap as to what we're going to talk about. So we're going to start with the emergence of big data. So to kind of lay the foundation here, big data, it's more than just a buzzword that you might hear. So when you think about data, an easy way to quantify that, or to think about that in some sort of concrete terms, is to think about zeros. And what I mean by that is a whole lot of zeros. So researchers at IBM kind of estimate that people create over 2 quintillion bytes of data per day. So that's a 2 followed by 18 zeros, right? So that's a lot of data. So when we're talking about big data, the volume is massive, right? So another kind of tidbit to think about is, would you believe that 90% of all the data throughout history that's been gathered was generated in the last 2 years? Sounds like a crazy fact, right? But it's also something that, to think about as we think about big data and what that means. So this rapid expansion of information is formally called big data. That's kind of happened over the last few decades, kind of emerged. So what exactly is it, and what does this mean, right? So we're going to take a quick look. So to give you guys kind of a background here, we're going to talk about kind of a short history leading up to today. So while gathering, storing, and making sense of information in general terms goes back centuries, we're going to focus on just a recent history here. So we had something called the information explosion that happened in the 1940s, which was kind of this, explosion of published information. A lot more stuff was published, made publicly available, and things like that. So that happened, starting kind of in the 40s. By 1970, we kind of transitioned to IBM publishing their first research paper on relational databases, right? So people started thinking about ways, okay, now we're really trying to organize this data in different ways. And you can think of this as kind of Excel spreadsheets, right? And that's kind of what it was. So in 1995, the internet was started to be commercialized with information only static websites. So it wasn't as dynamic or active as it was today. These were kind of static ways for you to view and access information, right? But this kind of changed the game in terms of how we access and how we see information. By 2004, you could, generate, distribute, store data on the internet, similar to, what you're available to do, today, right? So that was kind of the foundation of, information being widely available on the internet today. By about the mid 2000s, social media started emerging. So we have even more data that's being collected and used. So we have things like Facebook, Twitter, things like that are, collecting data and stuff like that. We also have YouTube and Netflix and other ways that you can view and stream other types of data, i.e. video content, right? So now that there's different types of data that are emerging and being collected as well. And then by about the mid 2010s, we have the rise of Internet of Things, which kind of led us to, today having a more internet connected world, right? There's a lot of devices that we use every day that connect to the internet, from our phones, automobiles, a lot of appliances in our kitchen, things like that, gaming consoles, our smartwatches, all that stuff. There's a lot of stuff that we have today that connects to the internet, and that whole interconnection of devices has led to the gathering of even more data, right? So today and moving forward, the scope of all this, big data is endless, and it becomes, widely useful in the world today. So today, more than ever, humans are kind of constantly engaged with devices that contribute to this flow of data, right? So this is kind of a big part of our lives, and it's kind of emerged at this big part of our lives. Something else to think about, by 2021, the average North American is expected to own at least 13 internet connected devices, right? So this is kind of that Internet of Things of where we are today. So things like phones, laptops, TVs, we talked about smartwatches, gaming consoles, your vehicles, stuff like that. These are all essentially data collection devices that we use every day. So to give you guys kind of a concrete example here, let's look at an example. So we'll talk about smartwatches. So wearable devices such as smartwatches can collect all kinds of data, and this data, becomes widely useful for not only you, but for the companies that collect it and all that stuff too. So what kind of things can smartwatches collect? Well, they have heart rate, fitness activity data, sleep quality, other things like blood glucose levels, and even fertility cycles. Just there's a lot of stuff that you can collect just with a smartwatch, Fitbit, or some sort of wearable device, right? So we have all this data being collected, but how is this even useful, right? So what on earth does this do? Well, just to give you guys kind of some examples to think about. So there's a lot of ways that this data can be widely useful and applicable, but this data in terms of this smartwatch could be used for things like helping a healthcare provider provide more personalized care, right? So they have more data on your actual habits of, are you, healthy? Are you taking a lot of steps per day? Or, what's your heart rate and stuff like that, right? So it's a way for you to actually monitor and have a more, a bigger picture for a, healthcare provider, right? Another example of this would be you could use this data for a health insurance company to personalize your rates, based on a bigger picture of your overall health and fitness, right? So these are, examples of ways we could actually use this data and all this data that's being collected. So I'm going to break down big data a little bit more for you guys, go a little bit deeper. We're going to talk about something called the 3 V's of big data. Just to give you guys kind of a bigger picture as to what that is and what that means. So we've talked about volume. So specifically, we talked about over 2 quintillion bytes. So today, the estimate is about 2.5 quintillion bytes of data that are produced daily by people. So to kind of put this in perspective as to how big that is, if you imagine each byte of data as a penny, 2.5 quintillion, which is that, that 2 followed by 18 zeros, or 2.5 followed by 17 zeros. If you laid that many pennies flat out, it would cover the earth 5 times over, right? So that's a huge amount of data. So that should give you kind of an example of the volume of data that's actually created. So some other kind of examples. So daily, there's estimated to be over 1 billion Google searches done, about 294 billion emails sent back and forth between people every day. Every minute, the estimate is, right under 66,000 Instagram photos are posted, almost 450,000 tweets, and, around 500 hours of YouTube videos are uploaded onto that platform, right? About every minute. So there's a lot of data going around, and a lot of this, is happening at a very fast pace. So the second V we're going to talk about is velocity. So the universe of big data is also expanding. A rate at which data is growing is kind of exceeding our ability to decipher it, which is kind of an interesting phenomenon. So there was a study done by IDC that estimates the amount of data in the world is doubling about every 2 years. And that's just because the rise of all these internet connected devices that's happened, and the amount of data that's actually being collected through those devices. Now, the other thing to think about is among that, only about 3% of the world's data is organized and tagged, right? It's structured in some way that can be organized. And actually, you know what it is, and it's tagged to a point where it's recognizable. And only about a 0.5% of that is actually ready to be analyzed and useful. So we have all this data, and we're actually gathering it faster than we can, decipher it or get it ready to be analyzed, which is kind of, a fascinating phenomenon, right? Another thing to think about is variety. So we also think about big data. There's a lot of different types of data that are being generated. A few decades ago, most data would be kind of this plain text. Think of like, data that might be in an Excel spreadsheet, right? Neatly structured. You have things like relational databases. And now it's kind of expanded into other things like audio, video, images, geospatial data, like your GPS data, et cetera, right? So there's a lot of different types of data. And each type kind of has this uniqueness in how it's stored, how we can classify it, what makes that format unique, how it can be analyzed, and how it's really useful, right? So it's really kind of a neat phenomenon and something to think about in the world we live in, and how this big data is continuing to change our lives, and how all this data can be useful moving forward. So I'm going to do a quick check on questions here. Okay, so it looks like we're all right on questions so far.
There's just one, Stephen, that I see offhand from
Sure.
pretty much you kind of covered it a little bit, but I'll read it verbatim. This is how can entrepreneurs find use cases for transferring learning in such a rapid evolving environment. Well, I was kind of thinking, like, you did bring some use cases up just recently about health, but you're always good at doing examples. Is that that might be covered a little bit later on in your talk
Yeah.
too.
Yeah, so we're going to go over a few examples later on how this data can actually be used and how it's useful, and some examples, kind of real world examples, how people have used this data. We're going to dive into machine learning and cloud storage and what that means too. But hopefully that gives you guys some more use cases here. But there is a lot with the rise of big data. There's a lot of use cases that you could probably find to give you examples on how people are using this data, right? And what this means. That smartwatch was an example, but hopefully we're going to go over a few more examples. And if you still have questions beyond those examples, how it can be useful, or use cases like you're saying, just let me know afterwards, and I'll do my best to give you guys some more too.
Sounds good.
All right, so we're going to transition here into the cloud. So this is kind of another big buzzword, and so we kind of talked about big data here. So what does the cloud mean, and how is this useful in the grand scheme of big data? Because this kind of plays a key component. So what on earth is the cloud? Well, the cloud is everywhere. We rarely notice it, but it is there. In the morning, checking email, checking traffic conditions on your phone. These are all interactions that you make with the cloud. While at work, you might use, if you're an engineer by some sort, you might use GitHub, as a code repository. You might, enter a customer information into some sort of software like Salesforce. You might onboard a new employee using something like Workday. You might view some of your old vacation photos on Dropbox or Google Drive, right? So these are all examples of cloud services. And we experience them, every day of our lives in many different ways. So why on earth is this called the cloud? How did that term even come about? And how does this relate to big data, right? How does this connect to what we just talked about? So the term cloud is kind of closely related to the internet. In kind of network diagrams that you might see a while ago, the complexity of the internet was shown as this cloud. And the reason was, it would, from an IT standpoint of somebody managing, let's say, the servers and the IT of a organization, the internet was beyond what they were actually responsible for, right? So you'd have some sort of a diagram to explain, the IT infrastructure of a company, and you'd have something like shown below, where the internet would be this cloud. And so with the emergence of the cloud today, they've kind of kept that term as a model to be able to share resources, right? You have on-demand access to things through the internet, things like data storage, software processing, things related to all those examples that we talked about before. So the things like accessing data storage, the software, pieces of the software itself, and actually the data processing might not be done locally on your phone or on your computer. It might be done behind the scenes in some sort of cloud service, and then you just kind of are able to quickly get the results and get what's important to you on your phone or on your computer, right? So which makes things a lot more convenient and accessible for us, as long as we have an internet connection, which is really cool. So big data in the cloud. So big data requires handling, these massive amounts of data that we talked about, right? Gigabytes of data, petabytes, these big volumes of data. So the cloud kind of comes about as the scalable environment that makes it really easy for you to store data and deploy data intensive applications, right? To be able to make an application or use an application that uses this huge amount of data, but not have to have all that stored locally, right, on your computer or on your phone. Because I imagine your phone doesn't have a petabyte of data storage, right? So it also simplifies connectivity for employees across organizations and all that other stuff, right? So there's a lot of advantages that have come about and are part of our everyday lives because of the cloud. And encourages things like innovative culture, because now you're spending more time creating and dealing with this data, on a creative kind of measure, versus actually managing servers and databases and thinking about, all that sort of data management things that used to be, kind of at the forefront, right? And you can kind of offload that into a cloud service nowadays, which is kind of a unique phenomenon, right? So we have talked about big data. We've talked about the cloud. We've talked about, how those kind of connect with each other. So, okay, so we have big data, and we, use the cloud as some sort of service for us to handle that big data. But what on earth can we do with this, right? Curling, is there any more questions? Just figured I'd do a quick check here.
You know what? That was the last one was one that you kind of covered.
Okay. All right. Just figured I'd stop and do a quick check.
No, that's good. That's good.
All right. So what on earth can we do with all this data? Well, one thing that's kind of come about over the last few decades is machine learning, right? With the avenue of, all this data being collected, machine learning is kind of this useful tool to be able to use that data. So at its core, for those of you that may not be as familiar with machine learning more than just a buzzword, at its core, machine learning is kind of a method for prediction. So this diagram right here represents kind of the what you might go through in some sort of activity in your life that machine learning might take part of now. So you might get an input from your environment, make some sort of prediction, make some judgment on that, on whatever that prediction is, and then make an action, right? These are kind of this decision kind of flow that happens in our everyday lives. And so if you can break some sort of decision down to having a prediction or that prediction component, machine learning becomes useful, right? And then that input can be, data from your environment, and that machine learning model can be trained on that data as well. So machine learning is kind of this data-driven solution. In general, the more data we have, the better predictions we can make on things and the more valuable they become. So data kind of has this three main roles in machine learning. In kind of a general case, we can use it for training. In other words, learning, right? For you to learn how to, add and subtract when you were young, you had to basically gather data of how that worked, right? You had to go through examples of, adding up, 2 plus 2, 3 plus 4, things like that, and learning how that works. And kind of the same analogy can be used to, machine learning, having, being able to use data to train it or to have it kind of learn, a situation. Data can also be used as input, right? Our current observation, after you learned how to add and subtract, if somebody gives you a problem, 5 plus 8, that's kind of the current observation or the current kind of input that you're receiving to make some sort of prediction and eventually a judgment on, right? We can also use it as feedback. So if we say that 5 plus 8 is 11, we have a feedback of, okay, well, it's, you were wrong. It's not 11, it's actually 13, right? So that feedback is also important to be able to make adjustments and actually get, were we right or wrong? So I'm going to jump into kind of a little puzzle here to kind of give you guys a little concrete example of machine learning's usefulness. So I want you to think about this puzzle and think about it kind of intuitively. So a bat and a ball cost $1.10, right? The bat costs $1 more than the ball. How much does the ball cost? So I'm going to stop this for about, 10, 15, 20 seconds and let you guys just think about that. And I want you guys to think about kind of the answer that quickly kind of comes to mind when you think about this.
I feel like I should give out some sort of prize, Steven. We're always giving out books and stuff like that. That sounds good.
All right, so hopefully that was enough time for you guys to think about that. So what does your intuition tell you here? So for most of us, a number kind of quickly came to mind, right? It was 10 cents, right? That ball must be 10 cents. But if we really kind of check the math here, the ball can't be 10 cents, right? Because if the bat costs $1 more than the ball and the ball's 10 cents, then we have 10 cents and $1.10, which isn't that cost that we talked about, right? This isn't the 110. So if you kind of resisted intuition, resisted that urge to just say it was 10 cents, you might have found the answer was actually 5 cents, right? Because the numbers kind of add up there, right? 5 cents, $1.05, you have that $1.10 total value. So this is kind of an example of intuition here. So I'm going to give you guys another question, and I want you to pay attention to intuition again, and then we'll kind of talk about what this means. So if it takes 5 machines 5 minutes to make 5 widgets, how long is it going to take 100 machines to make 100 widgets? Is it going to take 100 minutes, or is it going to take 5 minutes? What do you guys think?
Okay, this one deserves a prize. Someone chats in. I'll hook them up with something.
All right, so I know I kind of gave you kind of an A or B, right? 100 to 5 minutes here. So I'm gonna skip ahead, and you guys can kind of think about this a little bit. So what on earth does your intuition tell you here, right? So what does your intuition try to tell you is the answer? Now the answer, of course, is still the 5 minutes. But your intuition might have said, hey, it's 100 minutes, right? If it's 5 and 5 and 5, it's 100, 100, 100, right? So your intuition kind of tricks you here. And kind of both examples, these were made to be examples that, of human bias. So these are kind of classic examples of human bias, where our brains kind of look for the easiest route to get from A to B, right? They try to avoid as much strain and effort and actually having to think through a problem, analytically, right? They want to just get to the answer, move forward. So this is one of the reasons why machine learning in and of itself is useful, in that you can, avoid some of that bias that comes about by, examples like this, where we might be prone to bias, or we might be able to avoid that or mitigate some of that with something like machine learning, especially if we have a large amount of data to be able to feed that machine learning. So why does this mean machine learning is useful? Well, algorithms in and of itself can be less biased than humans in a general case. Now, there is a silver lining to this, and I'll give you kind of a concrete use case here in a minute. But your data can also be biased, which can lead to a biased prediction. Machines, or machine learning works very well with complex interactions between different, a lot of data. Think about like the movie Moneyball, right? Rich data sets are also kind of this sweet spot for machine learning. Some examples of this are fraud detection. There's fraudulent charges that might happen in your credit card that you never actually see, because they're detected and dealt with before they ever get to you, because of the machine learning that some of these credit card companies have actually implemented as a fraud detection. Another example of this is medical diagnosis, and we'll dive into a use case for that actually later too. So how can this data be biased? Well, here's kind of a concrete example about how. So in the 1980s, they kind of first started dealing with some of these big machine learning and AI problems. And one of the big things they tried to do was a team tried to use machine learning and try to build an AI to play chess. They wanted to be able to beat some of these great chess players. They said, could we do it, right? So they trained it on hundreds and thousands of different moves from these grandmaster games. Now, grandmasters are kind of these elite, kind of top level chess players of their day. And everything seemed absolutely great until they actually had it play someone, right? The AI established some sort of a strategy, had an attack, started playing, started having moves, and then immediately it would just sacrifice its queen. And so they said, what the heck, what's happening here, right? Why is this happening? Why is this AI just sacrificing its queen? We've trained it on all these amazing, grandmaster games, right? We had all this data that we've trained it on. What's happening? Now, what actually happened was when a grandmaster sacrifices their queen, it's usually kind of this brilliant and decisive blow, right? That's going to lead to a win. They do it for a reason. There's a strategy behind it. Now, this AI was trained on this diet of grandmaster games, and so that's all it knew. That's all the data that it had ever seen. So its prediction was that, hey, if I just give up my queen, that's the easiest way for me to win, because whenever that happens, these grandmasters win their games, right? So this is kind of a funny example, right? Of this, your data set can actually be biased and lead to this biased prediction of, hey, if I just give up my queen, I can win this game, because that's all, every time I've seen somebody give up their queen, it's this brilliant move that's going to allow them to win the game. So you can read more about this actual example in a book called Deep Thinking by Gary Kasparov, and it kind of goes into that a little bit more, what they did in AI in the 1980s and in playing chess. So another example here is sometimes when humans and machines kind of work together and we use kind of the best of both worlds in machine learning, where the data we have allows us to be effective in one manner but not effective in the other, prediction can become more accurate when we actually use both. So a concrete example of this, or a use case, is in 2016, there was scans of cancer and what isn't breast cancer. So they used both human and machine prediction, and they hit this very, very high accuracy rate, 99.5% accurate in looking at these scans, which was better than either one could do individually. So they tried to use kind of the best of both worlds, kind of have them work together, have these actual experts look at it and have, the AI actually be useful as well. So that's kind of crazy. So how on earth did they do that? How did they make these kind of work together? Well, first and foremost, they realized that humans were way more accurate in predicting when that cancer was actually there. And the AI was a lot more accurate at predicting when the cancer wasn't there. So they had the AI kind of look at it first, filter out the majority of the examples where there wasn't cancer, and then they passed everything else on to an expert and had them, make predictions and ultimately decisions on whether they thought, cancer existed or not, based on these scans. So what can we kind of learn from this? Well, for one, AI can work well when you have routine and rich data sets, right? They had a lot of scans to deal with, but also at the same time, when you can't really make a prediction with confidence, or it isn't really that accurate, we can also kind of use the best of both worlds and kind of cover those gaps with the advantages of, an expert where, machine learning might fall short. So kind of in retrospect here, big data and machine learning is this huge opportunity that's kind of presented itself over the last few decades. It's opened up a whole new world, savings, boosting performance for a lot of things that, tidbits to kind of think about, if anything, maybe some stuff that decision-making process, decision-making in their everyday lives, it's jobs, and create a lot of, industries that may not have existed. And data and machine learning are complements. So we talked about machine learning as a way to actually use that data. And so a machine learning model will ultimately, in a general case, be of limited value unless you have a lot of data to feed it. Now, thankfully, big data has kind of, been a driver of that. So if you are a startup, for those of you that are a startup and want to use this to your advantage, if it is data driven and you don't have access to that data internally, a strategy might be needed to actually gather that data, or to get the data you need to make that technology useful to you. And then a few more things to think about. So, we talked about big data, machine learning continuing to change our lives, but it also is going to bring about new challenges, such as, security, our, our reliance on a network connection, and actually compliance, right? If you're trying to use machine learning in the health profession, you have to follow HIPAA and other compliances that are set in place. So, that varies industry to industry, but those are also things to think about as well. But like we said before, it's going to solve a lot of problems. It's going to open up a new world of jobs, services, platforms, things like that. And there's also limits to what we can actually do today as well. And recognizing those limits of when, machine learning might be very useful based on the data we have, and when, passing that prediction actually off to a person rather than, using that data we've collected, also allows us to exploit, both of those strengths and be able to, ultimately provide a more robust solution than using each other individually. So that's the talk for today. Hope that it was useful for you guys. We'll open it up to some questions, and hopefully we can answer any of them and help you guys out.
Thanks, Stephen. Yeah, we had some really good questions. I know earlier about those use cases. We'll see if we can if that was answered correctly on that one. But the second question we had was really interesting. I've been studying some of this topic for a little bit, so I can maybe give some insight to this question too, Stephen. But
Sure.
pretty much it says I'll give a little synopsis, but basically it was the participant heard a term called hypermass datafication being cited in numerous papers from international institutions. Is this term interchangeable with big data, or is it a little bit off topic, so offhand? But the main thing is actually explain the difference maybe from datafication and big data.
Sure. Curling, you said you had some insight on that?
Yeah, I did. I think the one thing is actually just since we did a lot of data and we did a lot of research at USC on how we can use various data just to understand people. Datafication in some ways is how can you use data around someone's kind of like life or in different aspects to actually glean or inference from people or a little bit about it. One use case I've seen offhand was the fact that insurance companies using data from other streams, from credit card usages or other things to see if you actually are a profile risk for your insurance. So them getting other data from that. So one, I guess, key difference is for this datafication to happen, big cloud, like big data and cloud had to come about, right? We had to actually have some sort of really great platform to make this great kind of data warehousing of data. So datafication in some ways has been really, I guess, elevated because of big data and machine learning. That explains a little bit, but that use case about insurance was one. But one recently I've seen use case was there was like this map of the U.S. showing what states have been doing good at social distancing. And how they've been looking at that is actually looking at just cell phone data and seeing how that relates to how close people got, right? And seeing they were even certain states were graded worse than the other ones based on this data, right? So that's one use case of datafication. But I believe for something of that nature to happen, we actually needed to have these great platforms like Twitter and all these other platforms to bring in this great kind of profile of information that we can glean all this insights from. But I've been studying that for a while, so that was a little bit of my insights though, and how big data and cloud has kind of helped elevate some of those things. Hopefully that was helpful, Stuart. And the other one was the use case. In some ways, I think you did a great job on answering that, Stephen. But any other use cases?
In terms of maybe to bridge the gap between those two questions, I think you kind of answered the hyper datafication pretty well. But there's also been, I guess, something to add to that was you've seen kind of this datafication of a lot of companies over the past decade, and actually using where 10, 12 years ago they would have never thought to use data or whatever be useful in their business model. But now it's helped them make decisions and really transform, the ways they interact with their customers through their products or whatnot, right? An example of this that we might see in our everyday lives is if let's say you use your computer every day, you're, let's say using routine Google searches, maybe buying some products on Amazon, whatever else, you might see ads related to something you viewed before. And what that means is if you've ever, if you've ever actually watched, let's say a television program and an ad comes on for, let's say, some smoking medication, and you're sitting here thinking, well, I'm, 24 years old. Why? I don't need to listen to an ad about, smoking, right? Well, it's that concept of, okay, well, if we can learn a little bit more about you, we can actually have advertisements that are more relative to products that you might actually enjoy or actually might be valuable for you to actually see. So it's like kind of trying to change that, change that way that we actually view advertisements. And in that same way, you might see advertisements, on the internet related to, things you've recently searched or, stuff like that. So, and that's just data that's being collected at, say, hey, he's, looked up a lot of info on, running shoes. We're going to show him an ad for, some sort of athletic apparel, right? Or something similar, right? So you might see something like that. And then like what Curling said, where, hey, if we can learn more about a person, we can actually get a big picture on, how much risk they actually entail to get let's say, a loan or, have insurance and actually be able to customize, rates based on that. So those might be other, examples of how data is useful too. I hope that helps.
That was good. We got a follow-up question too. This is good. I feel like we always should have some sort of resources we give people after these, because it's kind of always like a lot of information for people. But I think the one thing is that what's the best resource for students who are kind of studying entrepreneurship? Okay, kind of want to understand a little bit more about how they can use these kind of data relationships using machine learning. So maybe some resources offhand. I know you've been reading a lot of different things. I've been reading a lot of different things, but was there some specific resources we can kind of like send out, or offhand for everyone who's listening?
Yeah, let me I'll see if I can
Curly,
get a
and I was
list.
thinking,
Yeah.
I think one of the big resources that's available for anybody to use with free trials is all the Amazon machine learning.
Yeah.
Apple has their machine learning. And so people can play around with those data relationships and data, try to get a better understanding. So that's just one thing that comes to my mind when I think of ways in which entrepreneurs can start tinkering with machine learning.
Oh, that's great, Sam. And I like how you actually brought, because I know offhand you guys are doing a lot of stuff with Apple too. But definitely on the Amazon side, and even for our current cohort, we're actually giving them Amazon AWS credits that actually has access to actually even using these kind of like a sandbox, right? To do some of these things. But Amazon does have some really good white papers too. The one white paper that came to mind when I seen the question was that AWS has this tool called SageMaker. It's kind of like using machine learning and creating models. And he had this really great article. I can send it out to everyone, talking about how pretty much the MLB, kind of like the National Baseball League, has actually used some of the technology. They have all these kind of like, you could actually profile certain people and profile batters and pitchers and do all these really great like simulations and somewhat real time on like, do we think that that person's going to be able to steal the base or not? Is this pitcher and this batter, what relationship it's going to have with that? Is it, so it's really interesting. So I'll send that article on that one because it shows how data is used kind of real time, helping with people just watching sports, which I think I love that. It gives people more realistic use cases, right? Because everyone watches sports and things of that nature. But that was one resource. But yeah.
Yeah, and one other thing to think about for those of you who are really interested and want to learn more, Sam mentioned some great ones. Curling, you mentioned some great ones. Google actually has a machine learning crash course that's pretty useful too, to help you kind of demystify, machine learning and learn a little bit more about how that can be useful as well. So there's hopefully, one of the things that Sam or Curling or I mentioned helps you guys out.
That's a great one. Thanks for reminding me about the crash course. I think that's all we built. Everyone at Google had to take this internally crash course, and then they released it for everyone else. So our engineering team has been using it, and we've been pointing people to the machine learning crash course too. Any more questions? And I was actually going to open up, Sam. I was going to have you. I know part of the cohorts on the call, but do you have any other any announcements or anything you want to?
Well, I was just going to make a couple comments for those who are doing kind of the entrepreneurial route and how big data, some of the things to think about. First of all, the way I teach is always about problem, solution, business model. So big data plays into all three of those components. Big data creates problems that need to be solved. We talked about a few of those: privacy, there's storage, there's transfer. There's a lot of different things that are related to the problems that big data creates. And so there might be some opportunities to try to solve those. Big data plays into solutions, and Curlian has shared a couple, is sharing about the base, but you can create products that you sell that rely on this machine learning tools and techniques to provide solutions to people's problems. And then finally, the business model. Big data can play into improving efficiencies within your business. Think of, for example, YouTube. I think they said 500, 500 hours are posted every minute on YouTube. There's no way, Stephen was saying that there's no way that YouTube could have a human review all 500 hours. It would be impossible for their operations to consider that. So they use, again, these type of machine learning algorithms to see what's being posted, whether it violates intellectual property of another person or company, et cetera. So in each of those quadrants, you can find ways in which big data, machine learning can play an important role in your business. So I think it's useful for anybody who is entrepreneurial to consider how can we use data, machine learning to have a better business.
Oh, that's great, Sam. I think we all have this kind of entrepreneurial spirit. So it's always fun to actually try to solve these problems with all this new technology. One thing I have, Stephen, I know you have been reading off some things, so I know we'll come up with maybe a resource list. We'll put it under the YouTube. What we have to do, we can send out an email with like a little resource list. But you've been learning a lot. Was there one book or one article offhand that you recommend? Yeah.
Let's see. I guess when we talk about human bias and things like that in terms of when it might be useful, there's a book that talks a little bit about that's kind of neat, called Thinking Fast and Slow. There's also a book that kind of goes into machine learning from kind of a business and entrepreneurial perspective rather than just like an engineering and strictly technical perspective. And that book is titled Prediction Machines. And we've actually, like, one of the talks that we've done prior, some of the examples are actually based off some stuff in that book. So those might be books to kind of give you a bit more insight on those two as well. But there's a lot of stuff out there, like Sam mentioned and Curling mentioned. There's a lot of resources out there for people to use.
Great. At this point, I think we can kind of conclude it. But I thank you so much, Stephen. This is always really fun too, because each time we do tech school, I told everyone like I learn things too, right? Because all of our engineering team always like reads different things, so it's always really fun. It's always a treat. It's always a treat for me too. And Sam's always very insightful too, and thanks, Sam, for coming on. Always give me this other aspect of this entrepreneurship lens, which is good. Like I said, we're going to be posting each week. Well, at least what we'll do is make sure all the resources we'll have on YouTube first. But if you just go to our website, we have a little new section called Tech School. We'll actually be kind of posting up certain things, maybe certain resources. We'll point you to some of those things on the Fōkcus website. And lastly, I just wanted to thank just a cohort. I'll do a little shout out to the cohort, people that came on to. We'll next week we'll continue meeting, and then once you kind of think about this kind of talk, and we can kind of like go over maybe specifics that can maybe help your group or your solution. But take care, everyone, and be safe and we got to stay healthy.